Howdy there, Internet students. Welcome to the new year and Unit 6.1. Today we're going to concentrate on classifying real numbers. Numbers have different types, and we need to know certain types. So let's move on to the next page. We're going to do this in 2 days, this lesson. The first day, all you have to do is watch the video and take notes. And then the second day, you can do the homework problems. Or if you feel like starting on the homework, you can go ahead and do that in your packet. All right, so we're going to learn how to classify numbers as natural, whole, integer, rational, and irrational, and how to order them. Okay, so first of all, let's talk about square roots. You guys have done this before, and the word square root comes from the square model. So if you have a 3 by 3 model, so 3 units by 3 units, we can represent the area by doing 3 to the second, which equals 9. Now, if we know that the area is 9, we can do the square root of that to get the side length of the square, which is 3. So basically, this is just saying what number times itself equals 9. Okay, and that's called a square root. Go ahead and fill in the rest of those. Hey, I just gave you a few for examples. There's a few more square roots that I think you should kind of get to know to help you out. The more of these perfect square numbers you know, the easier it is to decide how big the number is and make estimates and things like that. So let's go beyond the 10 by 10. Let's do these. The square root of 121 equals 11, and that's because 11 times 11 is 121. And so go ahead and do the next. So to figure out what the square root gives you 12, just do 12 times 12, which is 144. So I'd like you to do that up to 20. So what square root equals 13, 14, and 15, all the way up to 20. Later on, you'll see where these come in handy when you're simplifying square root expressions. All right, so to simplify a square root expression, if it's just a square root like this, you can go ahead and use your calculator, but that's why I had you, I gave you the list. So you're trying to think of what number times itself equals 25, and of course that's 5. Now when you have a fraction, you can just split that up. You can do the numerator and the denominator separately. So the square root of 4 is 2, the square root of 81 is 9. All right? So go ahead, you do this got it problem, and you can just check and see if you got your answer right. All right, now when we're estimating a square root, we can use those numbers that I had you write on the previous page, those extra square roots. So finding these will help you figure out about how big each of these numbers are on this next page. All right. So to estimate this, if the area has, if the area of the square is 220, so the area equals 220, that means that let's just call the side length S. That means that S times S is equal to 220. Okay, now there's no number that perfectly fits that, but we know that 15 times 15 is 225, and we got that on the previous page. So the square root of 225 is 15. That's a little bit too big, and if we go one square root smaller than that, which would be 14 squared, so the square root of 196 is equal to 14. We know that we can estimate that this area, or the side length here, is somewhere between 14 and 15. Okay? Likewise, the square root of 200 we know is going to be between 14 and 15, because 14 times 14 is 196. 15 times 15 is 225. And it's probably going to be closer to that one. All right, let's do one more together. We know that the square root of 36 is going to be a little smaller than the square root of 37, and that's 6. And the square root of 49 is the next whole number squared, which is 7. So we know the square root of 37 is somewhere between 6 and 7. Go ahead and try the rest of these. Sometimes you may need your calculator to help you out a little bit. All right, here's the answers that I came up with for those. All right, so the numbers that we deal with every day, we call those real numbers. So pretty much any number that you've seen up to this point is a real number. And we can describe them in two different ways that will help us determine whether the number is rational or irrational. If you turn the number into a decimal, one of three things could happen. You could get a terminating decimal, which is, these are examples, where it just ends and no more digits go on. You can have a repeating decimal, which you've seen those like 2/3, where the number goes on forever and ever, 0.6, or 3/11 just repeats 27, 27, 27. Or you can have a non-repeating, non-terminating decimal, like pi, where it just keeps going on forever and ever and there is no pattern in the numbers. They're just random numbers. Another example of one of those is like the square root of 6. If you check that out on your calculator, so if I do square root of 6, notice how the digits just are random and they keep on going. So when we write that as a decimal, we say about 2.44948997, and then we put dots to represent that that's going to continue and there is no pattern. So that we're going to call that a non-repeating, non-terminating decimal. Okay. Now, if the number is like this, where it goes on forever, but there is no pattern, then that's an irrational number. So we're going to say that's the non-terminating. So never ending and non-repeating. Okay? If the number either repeats or terminates, then we're going to say that that's a rational number. So irrational numbers are only those ones that go on forever and ever randomly. And here's 3 examples of those. Okay? Regular rational numbers may turn into decimals that repeat like this one, or they may just end like this one. Okay? Now, integers, whole, and naturals, they are not part of a number. They're just, they're whole numbers. Some are positive, some are negative. Okay, so let's review classifying these number sets. Okay, so natural numbers start at 1 and just go up by 1. Okay, and you should remember this from last year also, but this is just a reminder. Whole numbers start at 0 and go up by 1 at a time. So there's no decimals, no fractions in either of those. Integers are whole. They can just be negative or positive wholes. So they go to negative infinity and positive infinities, all whole numbers. Okay. Now, a rational number, you will remember, is any number that you can write like a fraction, where a and b are integers. So if it can be written as some number divided by another number, or those two numbers are integers, then it's a rational number. Okay? So since pi is a random decimal like that, it's not rational. Okay? But if we change, so what we're going to do is always change them to decimals and then look at them. Since negative 7/4 is negative 1.75, it's a terminating decimal. That one is rational. So we want to cross off pi. Now, if we do the square root of 5 on our calculator, the thing we see tells us whether it's rational or irrational. Since this number goes all the way to the end of the screen and it never seems to repeat in any pattern, we say that that is not a rational number. Okay? If it's a repeating decimal, like this one is, then it definitely is rational. Actually, 0.9 repeating is actually equal to 1, or 9 over 9, however you want to look at it. So we can write that as a fraction. And then 7.35, since this number ends, it is rational. So the only two we crossed out were pi and the square root of 5. Okay? So an irrational number cannot be represented as the quotient of two integers. There's no way to divide two numbers to get it exactly. Here's a couple examples. Okay, so let's do a few multiple choice problems. You can go ahead and guess, and then you can check back and see if you got them right. But read each question carefully, and then pick the answer that best fits that. All right, so in the first one, since the square root of 25 is exactly 5, that is a rational number because we can write that as a fraction. Just put 5 over 1. An integer has to be a whole number. The only number in the second set that's whole is d. If you look at the decimals for, well, if you do the square root of 9, that equals 3, which is a whole number. The only one on here that doesn't work out perfect is the square root of 40, and you can see that by checking it out on your calculator. You'll notice that that decimal goes on forever and never repeats. All right, and then the last one, any number that looks like a fraction where you're dividing two integers, a over b, which you are here, that's a rational number. Okay, so using these numbers, go ahead and put any on there that fit this description. The first one is an integer. Find the two rational numbers from the list and identify 3 irrational numbers. Now what I would do is have your calculator handy, like you're going to want to do the square root of 30. So and that'll help you decide that that is going to go down here with the irrational numbers. All right, so go ahead and list them where they go. All right, I think I'm going to stop here, and we'll start the video lesson tomorrow on page 5. We'll review all the sets of numbers again, and then you can do your homework tomorrow. All right, have a good day. See you later.